performance and scalability. Always a hot topic, particularly Bob, as you said, with the scale and size of some of these large deployments. Gopi, talk to us a bit about performance and scalability in Spinnaker. What's happened there, and what should we expect in the year ahead?
Yeah, as we just saw, some of these numbers speak to the size of the deployments that Spinnaker is doing. We think of scale as in both directions, right? When someone wants to start off small, can we make it simpler? And the other one is when you have fairly large deployments deploying to thousands of nodes, can you make it efficient? So the last year, there's a lot of focus on making it efficient in terms of deploying to fairly large ecosystems of applications. So this translates to not only the latency improvements in the delivery systems, but also in the cost of operations. And I picked up some of this that have significant impact here. Is one of the extensions that was done is external storage integration for pipeline artifacts. This is essentially when you're deploying with the multiple pipelines, one pipeline deploying multiple pipelines, or having large number of deployment manifests in the pipeline. The size of the pipeline context can be reduced by 70%, which translates to the cost of operation of Orca being proportionally smaller. So this directly translates to size of the machines that we are using to deploy and cost of operations. The similar one is in terms of search and caching of pipeline configs. Spinnaker is a microservice architecture with a lot of communication between services that are going on when you're deploying hundreds of deployments simultaneously. There's a lot of communication that's going on. And David Byron gave the talk last March on this one, what was done to improve that. We can look into that for more details, but essentially it's improving the search patterns within that and caching only the things that are required for executing those pipelines. And they saw almost 80% reduction in traffic. This improves the cost of operations by 30%, which is fairly significant when you're looking at fairly large deployments. And similarly, we have implemented the improvements in the caching of the service accounts. Spinnaker has fairly good RBAC structures for these resources that it's handling. And so improving the handling of that and the user management, we are able to improve the latency of some of the operations like pipeline creation or application creation by 75% in some of our customer environments. And of course, there are other improvements by upgrading to newer SDKs with Azure, improved baking support, or improved support for CRDs that makes the performance much better for Spinnaker. And the cloud driver also, we support sharding now. So if you're looking at 10,000 instances that you're deploying, having cloud driver 10 instances will reduce the amount of resource utilization proportionally. So that's, again, gives you a huge amount of cost savings. So we've seen both lower end of the scale, small enterprises deploying 100 pipelines, making it easier for them to use. And at the same time, large enterprises that are deploying thousands of delivery pipelines a day, make it much more cost effective for them to operate and run Spinnaker. And so there have been significant improvements, and we expect to see more coming.
I think that's one of the things that's remarkable, though, Gopi, about Spinnaker, right? It does support such a broad range of deployments in terms of size and scope, right? And the dual focus of ease of use for smaller deployments and performance and scalability for the larger ones, I think is part of the reason why the platform continues to grow and evolve and be a vibrant community.